So our first speaker today is going to be talking about some of the inventory work we've been doing, specifically nitrous oxide. Jiafo Luo is a senior scientist in the Farm Systems and Environment Group based at Ruakura. And here we go. Thanks, Jiafa.
Thank you, Tess. Good afternoon, everyone. I'm just quickly, briefly introduce our greenhouse gas nitrous oxide inventory work at AgResearch. As Nis just mentioned, why we do this work? Because it's required by the IPCC. So we have to report to the IPCC every year about how much greenhouse gas emitted from agriculture in New Zealand. Another aspect is, if we know how much emitted from agriculture, the government, the country will have developed the corresponding policy to target that climate change and greenhouse gas emissions. So how we calculate the greenhouse gas emissions, particularly nitrous oxide emission, we follow the IPCC framework. It looks like quite simple. Amount of nitrous oxide emission equal to nitrogen input time emission factors. Here we got two factors affect the total emissions. One is how much nitrogen input into our New Zealand agriculture. And then emission factor is percentage of the input nitrogen emitted as greenhouse gas. For example, 1 kg of urine deposit into pasture soil, 1% or 2% of urine nitrogen emitted as nitrous oxide. So another thing is we have to get the accurate inventory number, because that when we like to assess the mitigation effect, whatever we're doing, we use nitrogen inhibitor, we smartly use nitrogen fertilizer, whatever we're doing, we have to have the number to assess that mitigation effect. So therefore, we have to have accurate inventory calculation methods to catch this mitigation effect. Another thing is IPCC encourage individual countries to have their own emission factors. So that will have a little more accurate number for individual country. Otherwise, if we just use IPCC in the default value, like 2% for animal excreta, yes, we did use that before in New Zealand, and I will talk about it, we changed that. And for fertilizer, we also use IPCC is 2%, currently is 1%, but we also got a new emission factors for New Zealand fertilizer application, particularly urea application. So that is good, also good to the country. If we need to think about where is the hot spots, we need to target for mitigation. So we know where is the most nitrous oxide come from. So that is quite important for this kind of inventory research work. So we have been working with a range of funding organizations, particularly the New Zealand government, MPI, and we also work with PGGRC and the New Zealand Agricultural Greenhouse Gas Research Center. We also got a lot of commercial partners, like the fertilizer companies and some other dairy companies. So we have conducted maybe more than 8 trials around the country, different sites, different systems, and from about 2000, year 2000. So we have done a lot of work. So we look at is that emission, particularly from urine and animal dung. So that why we focus on urine and dung, because from our calculation, it's about 80% of total agricultural nitrous oxide emission come from animal urine and dung deposition. So this is why we focused on trying to look at the emission factor from sheep urine, sheep dung, dairy cattle, beef cattle urine dung. Of course, we also look at the fertilized nitrous oxide emission factors and the farm dairy effluent emission factors. When we do that, we also have to consider what kind of land use, how the land use affect the emission factors. The sloping in the hill country, soil drainage class, animal species, grazing system, how all this will affect the emission factors. For example, the grazing system, we know that that it's naturally urine dung will deposit to the soil. But nowadays, people like to do some wintering facility, so move the animal off the paddock. So how that will affect the total greenhouse gas, particularly nitrous oxide emissions. So that also is part of our work at AgResearch. So what kind of impact from that research? So maybe we just have a look at it that I just mentioned, the emission factor, we have developed it quite different from the IPCC default value. For example, the fertilized urea emission factor, currently we use 0.59%. The IPCC default value is 1%. Some countries actually still use 2%. So that is quite significant to the fertilizer industry. Their emission not as high as we thought before. One other important factor we investigated, we come up with the urine emission factor from 2%. Actually, in New Zealand, is about 1%. So currently, New Zealand IPCC value for animal urine is 1%. Another important finding is the animal feces. The nitrous oxide emission factor from animal dung is only 0.25, not 1 or 2% default value of the IPCC. So from that, this value I just mentioned actually currently already incorporated into New Zealand greenhouse gas inventory calculation. We can see this graph. This, we can have two reporting years. One is 2009, one is 2016. We can see the change from 1990 to 2007. So if you use the new emission factors, we can see that emission from nitrous oxide emission from agriculture actually increased by 4.5 gigagram nitrous oxide. But if we use the IPCC default value, the increase was 7.3 gigagram nitrous oxide. So in that way, as Liz mentioned, we may save a lot of money for the country if we get into the greenhouse carbon emission trading scheme or whatever the system in the future. Another thing is when we got all these precise emission factors, we can increase the accuracy of nitrogen footprint calculation. That is also quite important when we talk to the market, talk to the consumer. We are confident this is the emission from agriculture, from New Zealand agriculture. What do we think about next we need to do? We have to incorporate all the emission factors, country-specific emission factors into the greenhouse gas inventory calculation. For example, we have got some emission factors from the hill country, where obviously we know the no emission factor from steep hill compared with the lower slope hill. So that kind of data, we are currently working on it with MPI. MPI is prepared to incorporate into the inventory calculation. Another thing is we have to look at the hotspots emission area for nitrous oxide emissions, such as gateway and the trough area. So why we talk about that is because we may find the gateway and the water trough area may be only 10% of the whole paddock, but it may emit more than 10% of nitrous oxide, or even 20 or 50%. So if we know that hotspot area, we'll be able to target, mitigate this area. So we may like to apply the nitrification inhibitor or some other technology to the specific area where the nitrous oxide emission are higher. Another thing over the climate change over the time is that background nitrous oxide emission changes. So does that affect the emission factors? That is also another question we need to answer. Maybe lastly, the most important one is we should incorporate the mitigation practice into the inventory calculation. Whatever we're doing, whatever we try to meet the target for 2030 or 2050, we have to have the number, have to have incorporated the mitigation practice and technology into the inventory calculation. In that way, we are quite comfortable, confident about how much greenhouse gas, particularly in this case, nitrous oxide, is reduced. Thank you very much on that notes.